So before we start this new lesson, I thought I want to go back with you and review the concept I covered yesterday regarding the box, right? So yesterday we talked about this. I have four terms here, and I asked you to factor these four terms using the box method. And as you can see, yes, every time we have four terms, I can just go ahead and plug them into the box, right? What kind of size?
Where? 2 by 2.
2 by 2. We have four boxes. It's 2 by 2. So here is a 2 by 2 box, and I can just
review.
Yes, for now. And I'm just going to go ahead and fill it in. Here's the 2CD, here's the positive 8D, and here's the negative 4. Remember I told you there's some rules that you need to remember. For example, the very first line, if I cannot take anything out, I need to switch something right away. But if there's anything other than I want to take out, just go ahead and do it without any switching. So take it out. Is there anything for the first row that I can take out?
C.
A C. So I can take out a C. What about the second one?
4.
4. Any question on that? Just
No.
take out the GCF. Now that I have the corresponding side, I just go ahead and look for the top. C times what is C? 1. C times what is negative 2CD?
Negative 2.
Negative 2D. Okay, watch what happens. This is very important. As I check off, this is what people don't do often enough, and that's why you tend to get the wrong answer. You do not go back and check to see if you can multiply them and get the correct answer in the box. C times 1 is C. Check. C times negative 2D, is that negative 2CD? Check. Watch what happens. 4 times 1 is, whoops, 4. Negative 2D times 4 is negative 8D. Oh, whoops. So what happened? What does it mean? What does it mean?
You gotta switch.
You gotta switch. So watch what happens when I switch, okay? Here's the negative 4, here's the 8D. So when I switch it, the negative 4 will go here, and the 8D will go here. But when I switch it, I also have a negative in front. What did I tell you about a negative in front? You have to take that out too. So because of that, that negative will go outside, and look at this again. 1 times negative 4, negative 4. Negative 4 times negative 2D, positive 8D. Everything works out. You see it? You see what's happening there?
Yeah.
So because they're out of place, I switch. But because when I switch, I happen to have first negative. I told you about that rule yesterday. When I see first negative, I take that negative outside as well. And that's why this 4 becomes a negative 4. Okay? Is that... I mean, we're still applying the same rules. Nothing has changed. I just want to remind you about that. Okay? Alright. Take a look at this next problem here. And see if you can set up and do the same thing. Go ahead. I got 3p.
Do it?
Yeah, do it. Minus 2p squared minus 18p plus 27. I'm just going to draw the box. I'm not going to do anything else, okay? You can fill in the box yourself. You got yourself 3p. Here's a negative 2p squared. Whoops. I just stop right there. Next should be easy. Negative 18p, positive 27. See if we can actually take out. Is there anything to take out on the top?
P.
P. What about the bottom?
3.
Huh? Negative 3? Are you sure? Is that your greatest?
6.
27 is not divisible by 6. 9. Negative 9. Right? If you don't know for sure, I will set up a ladder problem outside and see if I can actually get that. But this is what I have so far. And then, I try to match it up to the top. P times what is 3p? 3. P times what is negative 2p squared? Negative 2p. So, once I have it, I start checking. That's good. That's good. Negative 9 times 3, whoops, out of place. You see it? So we know for sure that because it's out of place, I'm going to go and draw a separate box and show you what I'm going to do. It's just, no, it's a 3p, negative 2p squared, but because it's out of place, I switch. Here's a positive 27, and here's negative 18p. See that? Everything, though, will remain the same on top. And here, watch what happened. Because I switch it, and the first number is no longer negative, it's a positive, therefore this number right here turns back into a positive 9. You see it? So then, if you check it again, everything will work out just fine. So when you write it as a complete binomial of factors, you end up with 3 minus 2p, p plus 9. See that little adjustment you have to do towards the end? Because when we switch the terms, it's no longer negative first, right? So therefore, the outside has to be positive as well to reflect the change. So I have to do the little adjustment outside as well. Okay, any questions at all? So this is just a quick review on how to use the box. Today, though, as our lesson continues, I'm going to teach you how to use the X method. So when we use the X method and a box together, we call the thing X box. Yes, X box. Okay, so this is what I'm talking about. Start with the X. So how does this work?
What is it?
Yeah, I'll show you, don't worry. Well, the X works like this. I can, here are the two factors on the left and the right, basically the two numbers. When you take the two numbers and multiply them, you get the product up top. When you take the same two numbers and add them, you get the sum in the bottom. Okay, see how it works out? Two numbers add, bottom number. Two numbers add, the product on top. So if I go to here and look at the two factors that I have, 8, negative 8, and 5. If I multiply these two, what will I have? Negative 40. If I add these two, what will I have? Negative 3. Okay, you see the idea?
Yeah.
Alright, let's try this next one.
Is that it?
For now,
What do you for like that problem? Is that it?
you need to know how to set up your X, yeah. That means, see, you see how I can change the different of the position of the value? It could take different place value too. So you need to know how to find any in any location, so to speak. So I'll show you, don't worry. Just try to get this worked out first. What is this going to be on top? Negative 14. What about this? Negative 5. You see how that works? How about this one? Negative 66. Negative or positive? Positive 5. Because it's 11 and negative 6. Combined together, it's 5, right? Over here. Yes?
How do you get the bottom one?
Huh?
Bottom
Yeah, you add. Okay? And what about over here?
Negative 6.
Negative 6. Negative 1.
So it's called the Xbox?
X first, and then once we have it, we'll use the box later. So I'll show you, okay? Here, it's a little bit trickier. Because I do not give you the other factor, but instead I give you the sum.
Oh.
So what do you think this number is going to be? 8. Good, because 8 plus negative 2 is 6, and negative 16 on top. Okay? What about this? Negative 9. So negative 9 here, and the top number is going to be, huh? Okay, wait, think about this. The sum here is negative 3. I have a 6 here. 6 plus what going to give you negative 3? Is it negative 9? That's why negative 9 came down to be like that. And the top number is going to be negative 54. Remember, I told you there will be different variations too, not just this. So imagine, I can probably give you something like this, for instance, okay? What if I have something like this? I have the product of 42 and a sum of 13. Can you come up with two numbers that multiply to get 42 and add 13 to 13?
6 and 7.
Yeah, very good. You see how that works? So I can give you any location, you have to figure out to fill in the rest. So in this case, 6 times 7 is 42. 6 plus 7, 13. There's only one combination that works, okay? Not a lot. This is exactly one. But you can have different combination for different products, right? So just use that to guide you. But if you know how to do this, guys, the rest can be very easy. So let me show you the first problem. Yes. So here's the first problem. I got 14p squared minus 19p cubed minus 3q squared. And you say, wait, that's 3 terms. I need 4 terms to make a box. I'm missing a term, right? So how do we take a 3 and convert it back to a 4? Well, all we need to do is use the x that I just showed you to convert it. Easy. So here it is. For the x, let me show you how to get that set up. And please listen very carefully. I'm going to go ahead and code this to you to show. Yeah, converter. X is like an X converter in a sense. And then once we have it converted to a four-term polynomial, we can use the box like we do.
It's only gonna be 3 or that.
Yeah. So every time we have a 3 terms like this, we use the X to convert it back to 4. Okay. So this is how it works. I'm going to use color to code this, and watch what happens. I take the first number, and I take the last coefficient, so the first coefficient and the last coefficient, and I multiply the two together. That will give me my product. That's what I'm going to put on the top. So what is 14 times negative 30?
Negative 30. No, negative 40.
Negative 42. Okay, the question so far is how to obtain that top number.
So you always use it?
Yes, always use the first and the last. Multiply. Always. Okay, here's the bottom number, which is, this is how we're going to obtain the bottom number. The middle is the bottom. So every time I give you a trinomial, the two, the first and the last will give you the product on top, and the middle will give you the bottom number. Yes.
What about the variable?
Don't worry about the variable right now. We just figure out the number. Variable comes later. Don't worry about it. So right now, the question is, how do I find two numbers that will give me a product of negative 42? So that means when I multiply 2, I will get negative 42. And when I add them, I will get negative 19. Now for those of you who don't like negative numbers at all, pretend these are all positive. Find two numbers that will give you a product of 42 and add up to 19. Just stay positive for now. Two numbers.
7 and 6.
Huh? 7 and 6 is 42, but 7 plus 6 is 13. Won't work. Give me another.
9 and
Give me another combination.
8.
9 and 8, that's 72. What times what's 42?
Oh, 7 and 8. I mean 7 and 6.
7 and 8. No, that won't.
21 and 2.
Say it again.
21 and 2.
Did you hear that? 21 and 2. Why did I pick that? Well, look, 21 times 2 is 42. You know that 21 and 2, you can actually do something with 21 and 2 to make it 19, huh? You see it? So all you have to do is go back and say, okay, wait, 21 and 2, if I want to make this negative 19, then all I have to do is make what negative?
Negative 2.
Which one?
2. And 2.
Doesn't matter.
If you make this negative 2, then it's become positive 19.
Negative.
See? So which one has to be a negative?
Negative 20.
Negative 21. So it does matter. And then you also verify. Is it negative 21 times 2 negative 42? So that works. I just found it. Now for those of you who got stuff to say, how did you come up with that pair fast? Well, you don't have to come up with that pair fast. All you have to do is take that product right there, 42. Watch this. If I break it down, it's just 6 times 7, and 6 is 2 times 3, right? And 7 is just 7. Watch this. I can use this. Look, here's 21, here's 2. I can use different combination from there. You don't have to think in your head and just kind of write it out and try a different combination like that. And it works too. Okay? But remember, your goal is to make the sum equal to whatever number that is. And notice I don't care whether it's a negative or a positive. I just pretend they're all positive first, just to make it easier for myself to get the two numbers, and then I tweak the sign later. Okay? So once I have the two numbers, watch what happens. I immediately get rid of that middle term completely. I don't need that anymore. All that I need is to write the first term, which is 14p squared. Last term is negative 3q squared. And you say, wait, that means I only have two terms. Where am I going to get the other two terms to make it 4 terms?
Negative.
Guess what? You just found them. Negative 21 and 2. So we take that one right there and write it in. Negative 21 and positive 2. But do not forget, I'm trying to replace these two with, replace these for negative 19 PQ, right? So therefore, I need to make sure I put in the variable PQ and PQ. Okay, that's all that you need to remember. Because now, is it negative 21 PQ plus 2 PQ? Negative 19 PQ? You see it?
Yeah.
So I'm just using two brand new numbers to replace the middle term. But as I do that, I managed to make it 4 terms.
So we have to do that, then we have to do that box.
Yes, once I have 4 terms, then now I can use the box. Don't worry, this is just a first example. We have a couple more to go through. So, yes, Margaret.
So you take those two numbers out.
Yes.
Plug in where 19 is supposed to be.
Yes, exactly.
Both the variables and both.
Yes, yes. Okay,
Can you read the box?
so here's the box.
That's what we need about that.
14p squared minus 21pq plus 2pq and negative 3q squared. So what can I take out? 7 and p. What about the bottom? 1 q, or just q, right? The top, what can I take out? I mean, sorry, what do I multiply by? 2 p. And next one? Negative 3 q. So let's verify. Always verify once you're done getting the side and bottom, the left side and the top filled out. So it's 14 p squared. Good. Negative 3 times 7, that's negative 21, and pq is pq. Good. 2p times q, 2pq. Good. Negative 3q times q, negative 3q squared. Good. I got 4 checks. What do I do now? Write it. So as I write it, it looks like this. 7p plus q times 2p minus 3q. And that's how I factor. Done. Well, isn't this times that give you back your original form? You have to show me. Don't just set it. Don't just leave it, as a box. You have to show it. Okay. What happened? Yeah. It's coming. Here we go. Here's the next one. I got 30x squared minus 24x minus 54. So once again, I have 3 terms, and every time I give you 3, you need to convert it to 4. And if you know you're going to convert it to 4, you need what? The x. Then the box later, so x box. But if you notice something here, guys, if we're going to set up a box for this thing, an x for this, do you realize that the top number is going to be huge?
Yeah.
54, negative 54 times 30? Like, wait a minute, wait. Is there a better way to do this? Because these numbers are huge. Can I simplify to make it smaller? So you look carefully enough. 30, negative 24, negative 54. Do we have a GCF for all 3 numbers? 6. They're all divisible by 6, right? So because of that, I can say, oh yeah, I can take out the 6. If I take out the 6, what do I have left inside? 5x squared. Next.
Why do we have to put a 6 in front of negative?
I'm taking out the GCF. Ladder.
Negative.
I'm just simplifying, make it smaller for me. I mean, unless you want to take 30 times negative 54, that's fine. It works, but it's going to be big. Minus 4x minus 9. You see? Look, if you distribute back the 6, you get back the original trinomial, right?
So you have to have that 6 there?
Yeah, that's part of the factor, right? However, when I'm doing the x box, I just looked at the inside of parentheses.
So you have to multiply by 6 later though?
Yeah, later, when we're all done. But for now, just look inside of parentheses. So what is my number on top going to be? Negative 45. Very good. Here's the first. Here's the last. Negative 45. What about the bottom? Negative 4. Can you find me 2 numbers that will give me, notice I did not emphasize on negative, I don't care about that right now. Give me a product of 45 and a sum of 4. Don't worry about the negative. Just tell me 2 numbers that will give you a product of 45, 9, and 5. Very good. 9 and 5. Now I say, okay, how do I tweak these 2 to make it negative 45 when I multiply and add up to negative 4? There it is. Done. See? So just stay positive first and then change it back to negative later. So I know negative 9 and 5 will work for both. What do I do with the 2 numbers? Notice, I do not care about that anymore, right? See it? Once I have the 2 numbers, I just cross out the middle. So now I can write it like what? 5x squared
Wait, slow down.
Minus 9.
minus 9 what?
9
X, because I want to replace that term. Next,
plus
plus 5x minus 9. See? 4 terms. What do I do with 4 terms? Make a box. See? Once you get to that point, you know what to do with the rest. So I'm going to set up a box for this thing. Here's the box. 5x squared minus 9x plus 5x minus 9. What can I take out? X. What about this one? Nothing. So in this case, what? 1. Nothing means 1. Of course, this is a negative, and I'll take the negative with it, but this is positive, it's fine. X times what is 5x squared? 5x. X times what is negative 9x? Negative 9. So let's verify. 5x times x, 5x squared. X times negative 9, negative 9x. 5x times 1, 5x. Negative 9 times 1, negative 9. Everything checked out. What do I write?
5x minus
5x minus 9 times x plus 1. And here it is, Serena. Remember that 6 we took out way back?
You times it?
You times it back in. There it is. Just put it right in front, you're done.
Also, you don't have to distribute it?
Reason we just don't distribute is because, remember, we're trying to factor. Factoring, we break things apart. If you distribute, you put back things together. We don't want that. So that's all we're doing. So we try to break it apart, make it smaller, easier to manage. That's the whole point behind factoring. Okay, that's all we're doing. So the next problem's going to be the same kind of deal, and I really want you to go ahead and practice doing that. So here it is. Go. Try to take out the GCF if possible. Is there a GCF for all three?
Yes.
Yeah, then take it out. Once you take out the GCF, don't worry about it until the very end. Okay? Yeah. I'll wait. Just go ahead and do it. Yeah, all three. Do the ladder. Okay, that's fine. All right, so what can I take out? Is there a GCF for this?
Yes.
If the answer is yes, do it. What's the GCF?
3.
3. What else? See that?
What
A lot of people would just stop at 3, but you forgot about the variable.
3x.
3x. Isn't there an x to every single one, and the lowest one is just x? That's why I just take out that x as well. See it? Huh? What if you don't take it out? Let's say you forgot to take it out. What's happening is you're going to have it's not completely simplified or completely factored, so that at the very end you still have to factor it out. Not that it's wrong to say, okay? Well, eventually, if you don't factor out, the answer is not correct. Okay? So if you take that. Well, and besides, it'll make it a lot easier for you to take out the x as well. So if you take it out, what do you have left inside?
18.
6x
squared minus 7x minus 3.
See that? So I got that. Now what? How do I start? Use the x. What do we feel on top?
Negative 18.
Negative 18. Remember, I got that from 6 and negative 3, right?
Yes.
And the bottom?
Negative 7.
Negative
Oh,
7.
just kidding.
Got that from the middle term. Okay. What times what will give you 18 and add up to 7? Notice I don't care about the negative. We'll take care of negative.
92.
9 and 2. And now I go back and say, which one should be a negative?
Negative 9.
There. See it? So here's the negative 9, and here's the 2 that I'm going to be using. I just go ahead and rewrite the whole thing. 6x squared minus 9x plus 2x minus 3. See that? Any question on that? What do you think? What do I do with this?
No.
Notice how I replace the middle term with the two new factors I found. Once I have this, I put it inside a box, which becomes 6x squared minus 9x plus 2x minus 3. Is there anything in common?
3x.
3x. What about this one?
Why did
1.
you-
Yeah, go ahead, Ethan.
Why did you take out 3x? instead of-
Why did I take out 3x? Because what we're saying, GCF, don't we have to take out the number then and the variable if it's applicable? Remember how we do the ladder? We deal with the number first and then we deal with the variable second, right? So as long as I have something in common for the variable, I do need to take it out as well. That's why I have to take out the x. Because there are 3 x's here, there's 2 x's here, and there's 1 x here, right? And I know that I have at least 1 x in common, therefore I take that out. Okay? Now, let's continue on here. So 3x times 1 is 6x squared. 2x. 3x times 1 is negative 9x. Negative 3. So let's test this. I got 2x times 3x to be 6x squared. Good. I got negative 3 times 3x to be negative 9x. Good. You got 2x times 1 is 2x, and negative 3 times 1 is negative 3. Everything works out perfectly, and I can just write it like this. 2x minus 3 times 3x plus 1, and am I missing something?
Yes.
With 3x out in the front. So for those of you who said, what if I don't take out the x, right? Let's use that case. If you don't take out the x, well, what happened to you then? Well, you'll see this. You got 6x cubed minus 7x squared minus 3x. Is that correct?
Yes.
If you don't take out the x. And then you try to find out your x. Using the x method, you're still going to get the same result, isn't it?
Yeah.
Just negative 9 and 2. You put in the box. Or when you rewrite it, it's going to be 6x cubed minus 7x, negative 9x squared. You see how it changed the term? This becomes negative 9x squared. This becomes 2x squared minus 3x. You see it? You see how it's kind of different, a little bit different here? And when you put in that box, you have 6x cubed minus 9x squared plus 2x squared minus 3x. And notice that when you take out 3x squared, not 3x. You see it? Because of that little x that you did not take out to start with. And this here becomes x. Is that true? And here, when you multiply, you get what? 2x, and this is minus 3. So how's that going to change the problem? Not much. Watch what happened. You have 2x minus 3. You got yourself 3 from the beginning. And you got yourself 3x squared plus x. Instead of, what is it? 3x plus 1. But you say, wait, can I still take out the x here at the end? Yeah, you can. Look, isn't x and x here? I can take out an x. If I take out that x, I still get the same answer. Not that it's wrong, but you still have to do one extra step at the end. So it's either, I don't care what you want to do. You want to take out everything first, so you don't have to worry about it at the end, because you tend to forget at the end anyway. Or you don't want to take out everything at first, and then you have to take care of this at the end.
I didn't even take out the variable x, and I still have to write it.
No, maybe there's some miscalculation there. So please be very careful with that. Okay? So check this out again if you have to. But there it is. Any question on this? Okay. All right.